You know that little notification, software update available? You tap it, you wait a minute, and maybe your camera app has a new filter or something. It's simple, right? But what does an update really mean when we're talking about an AI? Well, it's definitely not about a new filter. It's something much, much bigger. Okay, let's get into it.
So right off the bat, we have to get this straight. A traditional software update, that's predictable. It's about fixing bugs, maybe adding a few clear-cut features. An AI system update, though, that's a whole different beast. It's a fundamental transformation. We're talking about something that can alter the core capabilities of the system, leading to these huge, sometimes totally unpredictable leaps in what it can actually do. And this transformation, it happens on a scale that is well, it's staggering. This is so far beyond your average download and install.
To get a large AI model through a single update cycle, it might process trillions of tokens. And a token is basically just a piece of a word. So imagine, we are talking about an almost incomprehensible amount of text and data, needing massive amounts of computational power, running for weeks, maybe even months on end.
And here's the really crucial point. This isn't about just patching a little security hole. An AI upgrade can be the difference between an AI that can describe what's in a picture and one that can actually understand the humor in it. It is a genuine leap from one level of intelligence to a completely new one.
So how does this actually happen? What's going on under the hood? Well, it pretty much boils down to 4 key areas, 4 pillars of improvement that researchers are always focused on. First, they can tweak the model architecture, which is kind of like building a better, more efficient brain for the AI. Second, they're always refining the training data, which you can think of as giving it a more advanced, more carefully selected education. Third, and this one is absolutely critical, is improving safety and alignment, making sure it behaves in ways that line up with human values. And finally, there's computational efficiency, just making the whole thing run faster and leaner.
A perfect real-world example of changing the model architecture is the transformer. I mean, this design was a total revolution. It allowed AI to understand context in a sentence like never before by weighing the importance of different words. It is the engine that powers almost all the advanced AI we interact with today, and you can bet the race is on to find the next big thing like the transformer. Now, because these changes are so profound, you can't just push a button and release the new version out into the world. No way. There's a really careful, methodical pipeline that every upgrade has to go through, from a wild idea in a lab to something that you and I can actually use. The whole process follows this super careful pipeline. It kicks off with research and development, of course. Then it moves into tons of rigorous internal testing. Step 3 is fascinating. It's called red team exercises. This is where they hire experts to actively try and break the AI, to find every single vulnerability they possibly can. And that's followed by yet another dedicated safety evaluation before it ever gets deployed to the public. So as you can see, safety isn't just a final check, it is woven into this entire process from the very beginning.
But look, this process is absolutely full of massive challenges. Pushing AI to the next level is a seriously high-stakes game, and there are some incredibly difficult hurdles to get over.
I mean, think about this question. It gets the heart of a huge challenge called capability control. Every time you make an AI smarter, you run the risk of making it less predictable. How do you guarantee that it's going to behave the way you want it to without any weird, unwanted side effects? It's a constant, delicate balancing act. And that reads right into the problem of evaluation complexity. See, unlike a simple software bug, a flaw in an AI might be incredibly subtle. It might only pop up in a very specific, very rare context once it's out in the real world. So how on earth can you test for every single one of those possibilities before you release it? Then you've got 2 more really practical problems. The computational cost is just astronomical. We're talking massive financial costs and a real environmental impact. And then there's this tricky thing with consistency. As users, we get used to an AI behaving a certain way, but an upgrade, by its very nature, is going to change that behavior. So managing that change for millions of users is a huge challenge in itself. Okay, so given all of those pretty serious challenges, what does the future look like? How is AI going to keep evolving? Well, the trend is definitely moving towards more sophisticated, more elegant solutions.
You can really see the evolution of these upgrades in 3 stages. In the past, it was all about brute force, just retraining the entire model from scratch every single time. Right now, we're in the era of more targeted, almost surgical updates. But the future? That seems to be pointing toward continuous and automated learning, where these systems might be adapting and improving in near real time.
And this is the real frontier. It's a concept called meta-learning. We are talking about AI systems that actually help identify areas for their own improvement. They might even propose changes to their own internal architecture. If this becomes a reality, it could accelerate the pace of development in a way that's hard to even imagine. Which brings us to the most important conclusion of all. As these systems get more powerful, and as they even start to guide their own evolution, the implications just explode far beyond the code. This is no longer just a technical problem for a bunch of engineers to solve in a lab.
And that leaves us with this final, and I think, absolutely critical question. As this incredibly powerful technology starts to learn and grow on its own, maybe at a speed we can't fully comprehend, how do we make sure that its evolution stays aligned with our best interests? How do we ensure that as AI improves itself, it also improves us?